I was recently asked why a neutral density filter needs to be used when you're trying to slow down your shutter speed. And one of the reasons that people use neutral density filters or want to slow down their shutter speed is to get that nice, smooth water movement, for long exposure. If water's moving and you're using a long shutter speed, then you can actually make it kind of blur out and get nice and smooth and soft and creamy. You get waterfalls that look like, I don't know, sugar, as opposed to being frozen in time with a fast shutter speed. So one of the things that you want to do is increase how long your shutter is open, and one way to do that is by using a neutral density filter. And the question that was asked was, well, why can't I just use exposure compensation like this dial up here, right? So here's how exposure compensation works. If I were to take this picture right now, the way it's metering it, it looks like it's going to shoot, and I hope you can see that, it's setting it at 1/400th of a second at f5.0. Okay, and you can change things with the ISO, but for the sake of this conversation, just to not confuse the issue, let's lock it in at an ISO of 80 for this discussion. You can move it, but actually it gets worse. If I go up to a higher ISO, the shutter speed actually gets faster. So you don't want to go in that direction. So 80 is actually, or the lowest that your camera will allow is actually the best that you're going to get. So I have it set to my lowest number. So again, right now it's set at 1/400th of a second, which is too fast, right? That's going to freeze motion, and at f5.0. Now look what happens if I dial this with a shutter speed compensation, the exposure compensation. If I dial it so I try to make it darker, now on the screen it's getting darker, so it looks like, ooh, I'm going to get a nice long, longer exposure. But what that's actually doing is it's trying to close down the f-stop as much as it can, so that it'll make it darker. So that's what exposure compensation does when you're in shutter priority mode, right? And the problem is you're going to run into a wall. So at 1/400th of a second, because I have this, I'm controlling the shutter speed in this case, you're going to run into a wall, and that wall is how small your f-stop will go. And in this case, my wall is at f8.0. That's for this particular camera. Now for another lens, another camera, it might be f22, but that's still a wall. That's still a limitation of the camera. And once you hit there, if you try to keep going, what's going to happen is it doesn't matter how much exposure compensation you do, you still hit that same wall at f8, and so your exposure is really not going to change. It doesn't matter how much you dial it in here, and it appears that it's going to take a dark picture, but it's not going to, because once you hit that wall of your maximum f-stop, which is the smallest hole to try to let in as little light as possible, once you hit that, then your exposure compensation is not going to work. So let me put this back to 0. Okay. And right now I'm at f50 and 1/400th of a second. Now let me try to dial my speed slower. Now 1/200th of a second. Notice the f went to 7.1. Okay. So in other words, it's trying to compensate because I'm using a slower shutter speed. But look what happens as I go to f1/125th. It hits that wall. Okay, so in order to get a nice blurred out picture, you really want to have like 2 seconds. So let me go all the way over there down to 2 seconds. If I already hit the wall, it's not going to get any smaller. So I'm at 1 second right now. I'm going to go to 2 seconds, which would be good for waves, right? Look what happens. It can't shut down the aperture any more than f8 on this particular camera, and so 2 seconds basically turns into blinding white light, because 2 seconds of light is too much. So in order for it to have the right amount of light, it's got to be way up here, like what we were before, like up at 1/200th of a second, or maybe 1/160th of a second. But that's the wall right there. So if you try to go to 2 seconds, the limitation of your camera is basically saying, no, I mean, at 2 seconds, it's just a limitation of physics. With 2 seconds of light coming in at f8, which is the smallest amount, and again, we're at the best ISO that we can have, which is very non-sensitive, right? You're still blinding it out. So the only way to compensate is to use a neutral density filter, and a neutral density filter will make this what would have been blown out white. It'll make it darker. It's sort of like sunglasses. You know, what you're using is a really dark thing in front of your lens, and what that does is it darkens it up so that you can shoot at 2 seconds at that f-stop. So it's as if there's less light out there, like it's a darker day, right? Like there's not quite as much light out there, so you're able to shoot at a longer thing. But when you're shooting at a bright light, let's say at a beach, and there's waves crashing around out there, and you're trying to slow it down to something like 1 second or 2 seconds, your camera simply may not be able to do it, and exposure compensation is not going to make any difference on it, because all exposure compensation is doing is it's going to either try to open up your aperture, shut down your aperture smaller in order to let in less light, but it's going to hit a wall, or it's going to try to slow down the shutter speed. But what happens is when you try to slow it down too much, just too much light is coming in. So the only way to compensate is by darkening the overall amount of light that's coming in by using a neutral density filter. And these, by the way, come in different darknesses. You can stack them, and you can make them darker. Like on a really bright day, you may have to stack all the neutral density filters that you can get your hands on in order to make it. I mean, this one looked like you could almost weld with it, right? Like it's so dark. You may not need this level of darkness, but that's exactly what it does. Is it takes the view that you would normally see, and then it darkens it so that it allows more light to come in. It allows less light to come in. And since less light is coming in, you can have it come in for a longer period of time, which will increase the shutter speed. Okay, I know that was a lot to take in. If you need to, watch this video a second time. Maybe it'll help you understand. One of the best ways is to just get out there in the field. Neutral density filters are not that expensive. You can get some decent ones if you just shop around. I like to get the neutral density filters that you can stack. These are two stacked up together right now, and you can stack them. These are 77 millimeters, and in order to attach it to this camera, by the way, I'd have to use a special inexpensive adapter, but it's the only way. It really is. It's the only way. Now, one thing that's going to happen, and a little pro tip for you, is when you're using less light and some of these neutral densities will cause a color cast. And what that means is it just looks odd, and it's no longer like the color that it should be. For instance, that basketball out there, if I use this on there, it just may come out strange. One of the things I like to do when I'm using neutral density filters, because less light is coming in and the color just shifts, is to use a gray card, and the gray card will help me with my white balance so that I can get a more accurate color cast and what it really was. Okay, hopefully that helps with your understanding of neutral density filters. For more information, head on over to pocketlenses.com. All right, talk to you later.